Good morning, friends, and welcome to another episode. In today's episode, we will be looking at two main things. So, we'll first look at relative atomic masses, then we'll look at relative molecular masses. So, I believe we can start with relative atomic masses. Now, relative atomic mass is usually represented by the symbol AR, the R being a small letter. So that's the symbol used to represent relative atomic mass. And it usually refers to the mass of one atom of a substance as compared to 1 over 12 the mass of carbon 12 atom. So this is usually given by this formula. So we have the mass of one atom of a substance divided by 1 over 12 the mass of carbon 12 atom. That is the relative atomic mass. Now, for those of you doing integrated science, you will not need to put this formula into your head. However, your friends doing elective chemistry will necessarily have to memorize this formula, and they would have to also learn about the calculation of relative atomic masses. And usually, in such calculations, the relative abundance of the atoms or the isotopes of a particular element will be given to them, and they will be required to use those relative abundances to calculate the relative atomic masses of atoms. But for those of you doing integrated science, you will not need to worry your heads with those details. In fact, in any questions that requires relative atomic masses, those numbers will be given to you, and you'll be required to use those numbers to do your calculations. Especially, you'll be given, let's say, the relative atomic mass of, let's say, some atoms in a molecule, and you'll be required to use those numbers to calculate the molecular or the relative molecular mass of that molecule, or for example, the molar mass of that molecule. So the details of these relative atomic masses you do not need for integrated science. But some relative atomic masses maybe you need to just be aware of. You don't need to memorize them anyway. A hydrogen, it has relative atomic mass of 1. Oxygen has relative atomic mass of 16. Chlorine, relative atomic mass of 35.5. Carbon has relative atomic mass of 12. Boron, relative atomic mass of 10.81. Beryllium, relative atomic mass of 9.012. So these are examples of some of the relative atomic masses. You do not need to cram them or memorize them. And also you need to remember that relative atomic masses are not the same as mass numbers. They are two different things. We learned in previous videos that mass number is the sum of the number of protons and the neutrons in the nucleus of the atom. Remember, that is different from the relative atomic mass, which is the mass of one atom of a substance divided by 1/12 the mass of carbon 12 atom. Please, you need to differentiate between the two. They are not the same. So I believe this will bring us to the end of relative atomic masses. We'll be going to the next item, which is relative molecular mass, Remember, in most calculations, you would usually, mostly, you'll be given the values of the relative atomic masses of the atoms involved. Let's quickly move on to relative molecular mass. This is also usually given by the symbol m small r, so relative molecular mass. And as the name suggests, it has something to do with the molecule. So the molecular mass, the mass of the molecule. Remember, for relative atomic mass is at the atomic level. So that's the mass of the atom. Whilst relative molecular mass is the mass of the molecule. So let me give an example. So let's say we have a molecule like H2SO4. Realize that this H2SO4 has atoms that came together to form it. So we have two atoms of hydrogen joined to one atom of sulfur to four atoms of oxygen. So these atoms were joined together to form the molecule H2SO4. Now you realize that the hydrogen has its own mass, sulfur has its own mass, and oxygen has its own mass. So the mass of the hydrogen times 2, which is the number of times hydrogen appears in the molecule. Then the mass of added to the mass of sulfur plus the mass of oxygen multiplied by 4 joined together will give you the mass of the molecule. So you realize that what is happening here is this: the individual masses of the atoms in the molecule are added together for you to get the relative molecular mass of this molecule H2SO4. And that's how you calculate relative molecular masses. And in most cases, you'll be given the relative atomic masses of the individual atoms. That's why I said earlier on. Then you'll be required to use the numbers to calculate the relative molecular mass of the molecule presented to you. We'll solve some examples, and I believe when we are done, by the time we are done with those examples, you'll come to appreciate this whole thing of relative molecular mass. So let's look at example 1. So in example 1, we start with a simple compound H2O. And our work is to calculate the relative molecular mass of H2O. We are assuming the relative atomic masses of the component have been given to us. So for hydrogen, it has been given to us as 1. For oxygen, it has been given to us, it is 16. We are going to use these values to determine the relative molecular mass of the hydrogen molecule. So first, this molecule contains 2 hydrogen atoms plus 1 oxygen atom. The mass of the hydrogen is 1, so that will be 2 times 1. The mass of the oxygen is 16, so that will be 16. So that will give us 2 plus the 16, that will give us 18. So the relative molecular mass of the H2O is 18. And remember, it doesn't have any unit associated with it. Molecular masses of substances do not have units. So we've been able to calculate the relative molecular mass of water. Let's look at another example. So in this example, you're finding the relative molecular mass of CO2. And here too, we've been given the following information which we are going to use for our calculation. Carbon is 16 relative atomic mass, and carbon is 12 and oxygen 16. Forgive me. So now to calculate the relative molecular mass, we need to add the masses of the individual atoms that come together to form this compound. So we have carbon plus two atoms of oxygen. So carbon, the mass of carbon is 12 plus 2 times the oxygen, which is 16 the mass. That will give us 12 plus 16 plus 16, that will be 32. So the two added together give us 44. So we have 44. That is the relative molecular mass of carbon dioxide or carbon 4 dioxide. Let's look at another example. So in this example, we'll be looking at NaCl. And in this example, we've been given the following information. The sodium relative atomic mass and chlorine's relative atomic mass. Sodium's relative atomic mass has been given to us and it is 23. Chlorine is 35.5. So we're going to use these values to calculate. So remember, the molecule has one atom of sodium plus another atom of chlorine. So we just add those atoms. So sodium is 23 plus chlorine it is 35.5. So the two added together give us what? That would be 0.58. That will be 58. So the relative molecular mass of sodium chloride is 58.5. Let's look at another example. So we'll be looking at another example next. We'll look at CaCO3. And the information we need for this calculation are for calcium, its relative atomic mass is 40. For carbon, it is 12. Oxygen, it is 16. These numbers will always be given to us. So now let's go on with our calculation. We have one atom of calcium plus one atom of carbon plus three atoms of oxygen. So calcium will be 40 plus 12 plus 3, 16. So when we add these numbers together, we get 100. So the relative molecular mass of calcium carbonate, calcium trioxocarbonate 5 is 100. It doesn't have any unit because it's the relative molecular mass. I believe we have to look at the last example, then we'll bring the lesson to an end. So here in this example, we have H2SO4 and the details we need for our calculation are the following. So we have hydrogen, relative atomic mass of 1. Sulfur has relative atomic mass 32, whilst oxygen has relative atomic mass of 16. So in this molecule, we have two atoms of hydrogen plus one atom of sulfur plus four atoms of oxygen. That will give us two. Mass of hydrogen is 1 plus sulfur. The mass is 32 plus oxygen, 4 of the oxygen, mass is 16. When we add these numbers together, we are going to get 98. So the relative molecular mass of H2SO4 it is 98. As simple as that. And please remember to differentiate between relative atomic mass and relative molecular mass. Relative atomic mass is at the atomic level, whilst relative molecular mass is at the molecular level. Relative atomic mass simply refers to the mass of one atom of a substance divided by 1 over 12 mass of carbon-12, whilst the relative molecular mass simply refers to the sum of all the masses of all the individual atoms in a molecule. So it's as simple as that. And you should be able to do these simple calculations. We're given a molecule and we have to determine its relative molecular mass when the relative atomic masses of the individual atoms have been presented to you. Once you are given something like that, you should be able to calculate the relative molecular mass of that molecule. I believe that will bring us to the end of today's lesson. We'll meet again in the next episode. See you, and please share the video if you've not already done that. Subscribe to the channel if you've also not done that. We'll meet again. Take very good care of yourselves.